In the previous videos, we've shown you different types of variables and how to declare them. We've also explained you the concept of conditional branches and how they can impact the flow of the code. In this video, we are going to show you a new pivotal concept of programming, loops. To explain you how they can be useful, let's consider a simple concrete case. Let's say you've been given the task of printing out the first 5 even numbers starting at number 2. The most straightforward way to do it would be to print them out directly with a print statement for each number as it is shown here. Pretty simple, right? Now let's say the task is slightly altered and instead of 5 we ask you to print out the first 30 even numbers. You could follow the same approach and add the 25 remaining print statements, but that'll take a lot of precious time. This is where loops come in handy. Loops in programming allow us to automate repetitive tasks such as the one we did before. Different types of loops exist, but for now we'll focus on the simplest one, the while loop. As its name implies, the while loop will do some action while something is true. In Python, the while loop is declared using the while statement. Similarly to conditional branches, it evaluates the truth value of an expression to decide whether the next set of statements has to be executed. However, contrarily to conditional branches, once all actions under the loop are executed, the execution of the code loops back to the beginning and reevaluates once again the conditional expression. If the condition is once again evaluated to be true, the program goes for a new round of execution, otherwise the program skips the set of actions under the loop and goes straight to the rest of the code. With our newfound knowledge of while loops, let's tackle again the problem of displaying the first 30 even numbers. We want to do something 30 times in a row, so let's set the condition of our while loop as being true only if something is below or equal to 30. This something can simply be an integer variable which counts each new execution of the loop. So let's declare a variable starting at 1 before the loop starts and let's have it be increased by 1 during the loop. This way, when the action under the loop is executed 30 times, the counter variable will increase up to the value 31, and thus the loop won't execute itself anymore because the condition will be evaluated to the value false. Now that we have a loop that can execute itself 30 times in a row, we can insert the print statement there. What required us 30 lines of code earlier is now written in just 4 lines. Another great advantage of using a loop in such case is that if once again the task is altered to require more than 30 numbers, only a slight change is needed in the condition of the loop. Loops can also be nested. Let's say you are given a new task requiring you to display the multiplication tables from number 1 to 6. If you think with loop, you can already write such a code which displays a multiplication table after each increment of I that happens in the while loop. However, there is still a remarkable amount of repetitive tasks happening inside the loop, as can be seen with those 6 very similar print statements. The solution? Replace it with a loop once again. What we get now is a loop within a loop that generates all entries in the multiplication tables from 1 to 6. In conclusion, loops are a powerful concept in programming which makes coding repetitive tasks easy and fast.